Okay, this is the second part of the endocrine system. I'm feeling a little sick. That's why my voice is like this. These hormones that you see in front of you are um, hormones from the anterior pituitary. And then once we finish this, we'll start talking about the posterior pituitary. And if you notice here, there are 6 hormones, so I'm missing one, and I'm missing prolactin at the bottom. Um, I'll hit that at the end. So here we have human growth hormone. And what does human growth hormone do exactly? Well, I wrote it out here. So it promotes the synthesis and secretion of IGF, insulin-like growth factors. And the target cells for insulin-like growth factors are places like the liver, bone, cartilage, skin. It's growing, so anything that's going to grow, and there's more target cells, but those are kind of like the main ones. So there's a few things that human growth hormone does, but I wanted to kind of, and that is these 3 things. So one, you have lipolysis. It means you're breaking up fat. So it breaks down fat stores, increased fatty acid use, and that's going to be for ATP production. So we're talking about, with ATP, we're talking about energy, all right? And then here we have speeding up the breakdown of glycogen to make glucose. So glycogen is stored in your liver and muscles, and that is like your blood sugar, but stored as a polysaccharide. And then when you break up glycogen, you produce glucose, and then it's a sugar. So the one up here, this first one here, is your fat, and then here is your sugar, your carbohydrates. And those are the 2 types of energy that your body uses the most often. In fact, if we were to kind of rank them, it's sugars first, carbohydrates first, then fats, and then proteins. Proteins can be used as energy. But here, in this case, with human growth hormone, proteins are used to make things grow. And that's the protein's first job. Before proteins are energy, proteins are going to be used to build anything, to repair tissue, to make bone, to make cartilage, collagen fibers, for example, to make anything, to make hair, whatever it is. So you're having an increased uptake of amino acids, so you're utilizing the proteins that you eat much better than before, and not only do you need the amino acids, but you need energy in order to take those amino acids and build them into different proteins, to build things in your body. So where are we getting the energy? Well, it's from ATP. And how are we getting the ATP? We're generating more glucose and more fat. So that's going to be, we're not generating fat, but we're breaking up fat. So that's going to cause somebody to obviously be more hungry and want to eat more. So you're speeding up the growth process. That's essentially what it is. You eat food and you take proteins and you make things from it, and you take carbohydrates and lipids and you use that for energy. So here we are with thyroid stimulating hormone. It tells you exactly what it does. It stimulates the thyroid to make T3 and thyroxine, which is T4. So T3 and T4. And those are going to influence your metabolism, speed it up or slow it down. Follicle stimulating hormone and luteinizing hormone are both products of GnRH from the hypothalamus. So follicle stimulating hormone does not only go to women but also to men. In women, it initiates development of ovarian follicles, and those follicles are going to make estrogens. It also forms something called the corpus luteum, which is formed after ovulation. We'll hit that in another chapter. In men, it's sperm production by the interstitial cells or Leydig cells. All right, luteinizing hormone, same target cells, ovaries and and testes. In women, it's going to trigger ovulation and then progesterone. Men, testosterone. I just realized a mistake that I made. Testosterone is made by the interstitial cells, alright, and sperm is made by the seminiferous tubules. Seminiferous tubules make sperm, seminiferous semen. Interstitial cells or Leydig cells make testosterone. Okay, ACTH, this is going to be a long one when we get to it. There's what are called mineral corticoids, glucocorticoids, catecholamines, androgens. We're going to spend, in a couple slides, we're going to spend some time on that. But it's all by the adrenal gland. So ACTH, the target cell of ACTH is the adrenal gland. Then we have MSH, melanocyte stimulating hormone. That's the target cell is the pineal gland, and although they don't know exactly what it does, it probably influences skin pigmentation, most probably like moles and freckles, things like that. But it's also thought to be an appetite suppressant or to maybe help with circadian rhythms like melatonin, probably to help with sleep. So we don't know for sure about that. So these are all the anterior pituitary hormones. All right, and so now we're going to move on to the posterior pituitary hormones. There's only two. Oxytocin, and that helps with, well, actually, before we get into this, the posterior pituitary gland doesn't make any hormones. It holds hormones that are made by the hypothalamus. The anterior pituitary does make hormones. It makes 7. The posterior pituitary only holds 2. So, and they are oxytocin and antidiuretic hormone, ADH, those two. So oxytocin is a little easier, so let's deal with that first. Right there, helps with uterine contractions and letdown reflex, which is the ejection of milk. The production of milk, that's prolactin from the anterior pituitary. That was the 7th one we missed on the last slide. Oxytocin, let me go back one slide. Oxytocin helps with uterine contractions. So let's talk about ADH. Antidiuretic hormone. Your blood, the amount of water you drink influences the amount of blood that you have. So when you have when you drink more water, you can literally have more blood than you had before. So that's me drinking coffee. So drink more water, that causes more blood. And then your kidneys filter through your blood about 30 times a day, and they're pulling out just all the stuff that doesn't need to be in your in your blood, and it's making urine. Your kidneys have a choice how much water it wants to take out of your blood to add to the urine. It could use a lot of water, then you're going to have watery, clear-looking urine, right? Or it can use very little water, and then you have like that nasty yellow urine, right? And that's because of antidiuretic hormone. So antidiuretic hormone is its effect is to keep blood pressure up. Your body doesn't have like a lot of mechanisms to lower blood pressure. It's really not built for that. It's made to raise blood pressure. So this is one of the ways. So if you have something like low blood pressure because of sodium loss, or you haven't been drinking a lot, that's going to start the release of antidiuretic hormone. Antidiuretic hormone is going to tell the kidneys to keep water. It's right here. This is what antidiuretic hormone does. It tells it to keep water and decrease urine output. That's one of the best things that the body can do to conserve water. Of course, we're also decreasing sweat and constricting arterioles, which are like a little bit smaller than arteries, larger than capillaries. They're kind of in between arteries and capillaries. So the other name for antidiuretic hormone is actually called vasopressin, vasopressin. So that name implies that it's constricting blood arteries. So when you constrict arteries, you raise the pressure inside. So those are the two hormones that are released by the posterior pituitary gland, or neurohypophysis. So not too difficult. Okay, now we're going to go to each one of the glands and look at it closer. This is the thyroid gland, and you see this is the larynx. So the thyroid sits just inferior to your larynx, and that bone right here, the thyroid cartilage, that is like your Adam's apple. So you feel for your Adam's apple and then go down a little bit, and there's your thyroid gland. When you look inside here, you'll see two different kinds of cells. This is the follicle. So whenever you have a bunch of cells in kind of a circular pattern, this is it makes a follicle. So inside here, we call this a colloid. C-O-L-L-O-I-D, colloid. All right, and then these are follicular cells. So I'll try to like underline it. Not really. There's one, there's another one, there's another one there. All right, what you're looking at, the circle part of that is the nucleus. So these are actually like cuboidal cells, and I'll see if I can kind of like make one. So something like that, right? I'm not really doing a good job on this, but you know, so they're cuboidal cells, and they surround the colloid. Right, so these are follicular cells. See all of these down here, follicular cells. And those follicular cells, which you can see they're marked right here, make T3 and thyroxine, or otherwise known as T4. And I'm very limited to how I can draw on this. And then you have parafollicular cells. So if you look at these cells out here, they're not part of the follicle. See, they're not up against this colloid, against this pink area. They're out here. What's neighboring them is another cell, not a colloid, or not a follicle. So we call them parafollicular cells. They're near the follicles. And they make calcitonin. I'm writing CT here for calcitonin. And calcitonin is going to lower blood calcium. So, and we're going to talk about that hopefully with this next slide. No. So before we get into that, let's talk quickly about how thyroid hormones are made. Your book has a lot of steps. It's essentially, thyroid hormones are essentially made of two things. They're made of a protein and iodine. So right here, you see these iodines. Right, so this is supposed to be your blood vessel right here, and this is the cell. This is one of the follicular cells. Like here's another follicular cell right here. And there's another follicular cell right here. Right, so this is supposed to be, you know, going around in a circular motion. Here's the cuboidal cells. So we like make a couple cuboidal cells here. There's like another cuboidal cell. Alright, so that's what this is supposed to be. It's supposed to be cuboidal cells. And this is all supposed to be colloid in the middle. So the first thing it's going to do is what's called iodide trapping. Follicular cells are going to pull iodine from the blood. Alright, and so here they are, they're pulling iodine in from the blood into the cell. Now you notice here, it's an anion, it's negatively charged. But here, once the iodine's inside the colloid, it's not. So it's going to take it, it's going to bring it into the cell, it's going to remove the negative charge, which means that it's removing electrons from it, and that will take away the charge. And then once it's here, it's just regular iodine. And I2 means two iodine molecules put together. So, take an iodine, the follicular cells take an iodine from the blood, removing the electron. It's no longer an anion, it's just a regular iodine. And there it is in the colloid. The other ingredient is going to be a protein. So right here, synthesis of TGB, thyroglobulin. So the cell at the same time is making thyroglobulin and putting it here into the colloid. See, there's TGB and there's iodine. Those are the two ingredients. When you put them together, this whole thing here is supposed to represent T1 and T2. So when you put TGB into the colloid and you put iodine into the colloid and they're mixing together, they make T1 and T2. Some of those T1s and T2s are going to get together. It's lonely in the colloid. They're going to hook up and make T3. Some T2s are going to hook up with other T2s because it's 2014. And they're going to make T4. So the finished product is T3 and T4. The cell's going to take this finished product, T3, T4, here it is here, it sucks it back into the cell, and it's going to push it out back into the blood. So it's going to bring it back into the cell and through exocytosis, put it out into the blood. So here's the T3, and here's the T4 back in the blood, the finished product. There's our thyroid hormone. Here we have something called TBG. If you look down here, thyroxine binding globulin. That's to confuse you because we have TGB, so we have to do TBG to make it worse. But TBG is the protein that T3 and T4 ride on, because T3 and T4 are lipid-soluble hormones, so they can't just go into the blood. They need a transport protein to ride on. And there you go. So that's how thyroid hormones are made. I'm going to stop this, and I'm going to do a part 3. Well, no. First, let's talk about the effects of thyroid hormones. What do they do? Well, we know it raises the metabolism, but how? What exactly does it do? Well, if you look down here, you have a few things. Stimulate lipolysis. So there again, we're talking about increased use of energy. Increased use of glucose and oxygen for ATP production. So this is, both of these that I underlined are about making more ATP, about making more energy. The effect of that is that's going to increase your BMR, your basal metabolic rate. When you make more energy, you're going to increase your metabolism. The other effect of that is what's called the calorogenic effect. Increase your body temperature, right? So they're listing them here as like actions, but these, increasing your body temperature, increasing your metabolism, those go hand in hand, and those are both effects of using more sugar, using more oxygen, and breaking up fats to use for ATP. All of that's used to make ATP. Alright, and then you hear, and all this should look kind of familiar to you because we talked about it a couple slides ago, protein synthesis and accelerated tissue growth. So we're making more proteins and growing tissue, and it sounds a lot like human growth hormone. So okay, I'm going to stop it here, and I'll do a part 3.